So at this point, we've covered Java reentrant lock, one of the core synchronizers. We've covered Java semaphore, which is another core synchronizer. And now we're going to turn our attention to yet a third core synchronizer called Java ConditionObject. And this is arguably the most complicated of the ones we've covered so far. So we'll cover it from a bunch of different perspectives. And I'll start out by giving you an overview of what the underlying abstraction is about. And the underlying abstraction of Java ConditionObject is something that's called a condition variable. So it turns out that condition variables can be a little tricky to understand and to use properly. Although once you get the hang of it, it's really not that hard. So you may want to come back and rewatch these videos multiple times. You may want to read the links carefully. You may want to look at the example we're going to cover later, probably not this class, but next one, that shows how to use condition objects in practice. And the actual example we're going to look at to illustrate the application of condition object is to finish off the Java array blocking queue implementation. We'd originally used array blocking queue earlier to show how reentrant lock could be used to provide mutual exclusion in critical sections for the take and put method of array blocking queue. And now later in this set of lessons, we're going to talk about how condition objects are used in order to coordinate interaction between multiple threads that are calling take and put concurrently. And of course, as is always my tradition, I'll give you a fun human known use of condition objects just to hopefully make it be a bit more intuitive. So what is a condition variable, or sometimes called a CV? It's a synchronizer that allows a thread to repeatedly suspend its execution, or potentially repeatedly suspend its execution, until a particular condition is satisfied. And so it'll typically keep doing this over and over again until it gets what it wants. And that's very important to understand, is that this particular abstraction works very differently from semaphores and reentrant locks for reasons we'll talk about in a second. The thread whose execution is suspended on a condition variable is said to be blocked on that condition variable. And we'll talk more about what blocking means here in a second. In fact, that's probably the main difference between a reentrant lock and a semaphore and a condition object or condition variable. Reentrant lock and semaphore basically are used to keep other threads at bay until someone can get access to something, whereas condition objects are used to put a thread to sleep until something changes to be more to its liking. And so it's a little bit different in the way it works. Condition variables are often used when mutual exclusion alone is inadequate. And there's plenty of situations where mutual exclusion doesn't get you quite what you need to have. So one example, which we've talked about a number of times and you've had a chance to play with, is the use of Spinlocks, which can lead to excessive resource consumption and resource utilization due to so-called busy waiting, where you sit there and spin when you can't get what you want, and that's inefficient. Another challenge with mutual exclusion and reentrant locks and so on is that they don't allow you to perform effective coordination. And coordination is really all about what does a thread need to do when it encounters some condition or some values of its shared state that don't allow it to make any progress. And a classic example of this, which should be very intuitive, is waiting when a list or a queue is empty and you want to acquire or take a value from that list or queue. So obviously that's a case where you need to coordinate. You need to kind of go to sleep or block or wait, if you will, or suspend yourself until the list or queue becomes non-empty. So that's a variant, and just spinning isn't necessarily the right thing to do because you could spin for a while and that's very inefficient. So to alleviate these various inadequacies with mutual exclusion and the more basic primitives like reentrant lock or synchronized statements, synchronized methods, condition variables are implemented as a queue of threads. And the queue of threads is referred to as the so-called wait set. So if you read the documentation and you read about the wait set, that just means it's a queue of threads that are waiting their turn to get access to some shared resource when conditions are in their favor, when the conditions are aligned to what they need to make forward progress. So rather than spinning, which is what you can do with the basic mutual exclusion primitives, threads can choose to wait for certain conditions to be satisfied. And in particular, while the condition you're waiting for is not satisfied, you will basically wait. So we'll talk more about that in a second, and I'll show you some more detailed programming examples. But first, let me give you a funny, whimsical example of condition variables from everyday life. So the example we're going to use here is a pizza delivery protocol. So let's say that you've decided to make some extra money while you're a student, and you decide to deliver pizza, because delivering pizzas, pizza chains are always going to make money, because when times are good, people order pizza to celebrate. And when times are bad, people order pizza to feel better about themselves because it's kind of a comfort food. So pizza is like a perennial good industry to go into. So you could be a pizza delivery person. And the way that this works, if you want to deliver pizzas, is say you and a bunch of your friends decide to work at the pizza delivery place, like a Papa John's or Domino's or whatnot. And here's how this works. You sit around in the waiting room at the pizza delivery, at the pizza parlor, and to deliver a pizza, you need to have two pieces of resources. First, you have to have a pizza, because you can't deliver a pizza if you don't have a pizza. And you also have to have the keys to the delivery van or the delivery car. That's what's going to be used to actually deliver the pizza. And so if you get both of those things, if you get the pizza and you get the keys, then you can go out and deliver your pizza to the customer. But if you can't get both of those resources, if you can't get the pizza and the keys, then you go back to sleep. And of course, this is a second job, so naturally you're going to want to get some rest when you're not out delivering the pizza. So you'll sleep until those resources may be available. And the key is may be available. And the way that this works is whenever the cook finishes making a pizza, they ring a bell, and that signals all the waiting pizza delivery people that there could be a pizza in their future to deliver. And whenever a person comes back from delivering a pizza, they put their keys to the delivery car, the delivery van, on a hook, and they ring a bell. So there's two situations under which you get notified. And whenever the bell rings, you wake up, you and your buddies who are sitting around waiting to deliver pizzas all wake up, and you immediately try to get the keys and the pizza. And it's very important that you always try to acquire them in the same order, because if you do, one person grabs the pizza and tries to get the keys, the other person grabs the keys and then tries to get the pizza, you'll very quickly end up with deadlock. So the protocol is when you hear the bell, you wake up, you first try to grab the pizza, and then you try to grab the keys, or vice versa. And only if you get both of those things can you go off and do your thing. Otherwise, you have to go back to sleep, waiting for that bell to ring again, notifying you that you might get a chance to get the resources. And in fact, it could be the case that you get the pizza, but you can't get the keys, in which case you have to release the pizza. Okay, so that's basically the simple example. You'll see when we get into more details about how condition variables work and condition objects work, that all the other variants that we talk about from a more technical sense, like trying to remove something from an empty queue or trying to add something to a full queue, all boil down to the same pizza delivery metaphor that I've just given you as the human known use.